So this is the add-on at risk. Now it luckily did start, and there you have a lot of options, like this section is for defining your model, then this section is for the simulation itself. Here you have a results section. There are some different tools you could also use and try out, but we won't use these, and some adjustments for the software. So firstly, you have to designate your risk or your at-risk outputs, and at-risk outputs are these cells you are interested in analyzing. As I said before, there is a table for the key performance indicators, and today we are interested in the internal rate of return, for example, and in the equity multiple. So we are analyzing these two KPIs on how they are changed when we change our input variables. And therefore, at risk calculates the probability for each value, and also at risk cannot predict the future because or there's no future outlook. It's only a calculation of the probabilities, and the model is only as good as realistic your input parameters are. You're looking puzzled?
Can you say it again? It was equity multiple and?
It's equity multiple and IRR.
IRR.
Yeah, internal rate of return. So, and therefore you could define these KPIs as an output, and it's just that you are click on the cell, and then you're going to for me it's Ausgabe hinzufügen. For in English it's maybe designate output or something. And so this is the first KPI we want to look at, and we just say we click the button, add output, and so here we can add or change a name for it, for this output, and this is slightly important because this name will appear on several reports you can print after the simulation. So, but we keep it like it is because it's the name of the cell on the left side of it, so that's okay. And then we are using the equity multiple. Also, we are doing the same. We are just clicking on the cell and designate output, and there I would say we name it only equity multiple. All right. Maybe you recognize that the formula changed. So this is the way how at risk makes it, or how at risk is obvious in your formulas, that it's adding like here risk output. So then it's obvious that it's the output you just defined before, and its name is equity multiple. All right. So then I showed you how I did calculate some of my input parameters. I told you that I had some given input parameters out of the literature or some information from banks, and all these input parameters, they are very uncertain, and for this reason I implemented this table with the different cases, or with the different adjustments I could imagine. So and here it's very important that your adjustments for best and worst case, that they are very realistic. And you just or you assumed your input parameters, and at risk now helps you to get some probabilities of these parameters. All right, and now we want to test, for example, how are these KPIs influenced by your construction costs, by the exit yield, and by the interest rate for your debt.
Exit yield is the same as its cap rate.
Sorry?
Cap rate and yield are the same, right?
Yeah, in this case, it's used as the same. Like the rent at the end of your development is capitalized with the exit yield to get an exit value. Yeah, yeah. But the definition is slightly different. Yeah. But
why you just called it cap rate?
sorry?
Why you just name it cap rate?
Because in this, yeah, in this case, you're just defining it as cap rate because the name exit yield just is taken into account when you use it as an exit yield. Like it's a thing of defining it. Like when you are a developer, then you derive your cap rate, and when you're using it for the calculation of for exit value, then you could call it exit yield, because then it is an exit yield. But the basis should be that's a cap rate, and that you could also use it different. For example, you could also use the cap rate as you mentioned as a weighted cost of capital, WACC, for example, or for the calculation of the net present value, for example. You could also use the cap rate. But when you define it as exit yield, then it's obvious. Then you capitalize your rent in the end of the development. All right. Okay. So we want to try how the parameters construction cost, interest rate for your debt capital, and the exit yield are influence the KPIs which we just defined as an output. So, and we are starting with the construction costs, and here you also click on the cell in the most likely case, the base case, and there you just say Verteilung definieren, so to define the distributions. Hopefully that's the translation for the English version. And just click on it, and then a new window opens. There you can choose whether it's or how the shape of the distribution is, and normally it's only normal distribution or triangular distribution. Normal distribution, I hope that's in your knowledge. Like for a normal distribution, you need a mean, an average, and a standard deviation, and then it's distributed symmetrical, and in this case we have a triangular distribution because we have one peak, that's the base case, and then we have a minimum and a maximum, that's the best and the worst case. So you are defining it as triangular. Alright. So here you can see how the construction costs are displayed in a triangular diagram, and here you already have your base case value, and a suggestion from the software what should be your minimum, what should be your maximum, for example. And there it was also good to calculate it beforehand, because now you could just implement the calculated values for your best case and your worst case. And this is what I want to do now. So I have the minimum, and that's 17,757. Then the maximum value, that's the worst case, when my construction costs are very high. No, it doesn't look like this. What's happening here? So that's not right. I don't know why. So we just set it as 20 millions. And one step back. Alright, so this is the triangle after you implemented your values for the best case, best, worst and base case. And like this we are doing it for all the parameters we want to check. Like this has been the construction costs. Now we are going on with the interest rate. Also here, defining the distributions. It's also triangular because I didn't calculate any average or standard deviation. So the minimum is here. Maximum. So I just copy and paste the values which are calculated for the best and worst case. And finally the exit yield. Alright, so that's the last or final distribution we want to define. And now
could you also set a likelihood for the different exit yields, cap rates separately? for example, saying like with a 50% likelihood we're gonna get 6.5%, with a 20% likelihood we're gonna get 6.15%, with a 30% likelihood we're gonna get 7%.
Yes, but this would be more in the normal distribution and not in the triangular.
But wouldn't it be more like, isn't it called histogram? Like if you're...
And I know what you mean. Yeah. I'm not sure about this option, but yeah, isn't it like you're setting in the normal distribution the mean, the average, and then you have your standard deviation, how likely it is that the values are or how big the distance is from the values to your mean. Isn't this what you want to calculate?
I'm not talking about a normal distribution. Is there kind of line?
Here.
Like with a 10% likelihood, I'm gonna get 5% exactly pure calculate. With a 50% likelihood, I'm gonna get like 6%. I'm making it discrete. Is it also possible?
But this is more or less what we get as a result for the outputs. Like afterwards, you see with a likelihood of 10%, we are getting an IRR or an equity multiple of 2.
Okay.
Adrian?
Yeah.
You mean like this?
Yeah, exactly.
Yeah,
Yeah.
so there's an option. So
there's
you
an
just
option.
have to switch to German discontinuity.
Discontinuity. Okay.
And then it should be possible.
Okay.
I don't know how.
Yeah, but if you define it in the in this distribution, like you mentioned, I think this would be implement more uncertain values. Like you have to assume more parameters in this case. Of course, you can do this,
Okay.
but I'm not sure whether it makes the model better or worse. Okay.
How about it, like, for example, like, just to illustrate, if you, for example, talk to a bank and they tell you, most likely we're going to give you 2%, so you can assign a probability 9% to 2%, and then you just account for some other, like, 2.5, 5%, and like...
Yeah, I know what you mean. Yeah. But yeah, you have to take into account that it's there are more parameters which are uncertain implemented by your own, because it's your opinion, and if you cannot derive them in a feasible manner, then I wouldn't do it, to be honest.
Okay.
Yeah. All right. So this was the last distribution, and this was most of the work for the simulation. You also see that the formulas for the cells we just implemented the distributions that they are changed from at risk, and now you set your iteration steps, and this is important because the higher your iteration steps, the higher the more accurate is your simulation. And the downside of this is, of course, the higher your iteration steps, the more time is needed for your computer to calculate it. Normally, I think 1000 would be enough because it's not that, or the model is not that difficult, and we just took into account like 3 different distributions or input parameters, and we only have 2 outputs, so therefore we are setting it to 10,000.
Sorry to interrupt again, but what specifically is it iterating?
The iteration means that now there are 10,000 steps or 10,000 different values implemented in the model, and with these 10,000 different options or implementations, the simulation is calculated. like it's a Nährungswert, to get closer to a realistic value, or to make it more accurate.
So it's taking a combination of the three input variables,
Yes.
varying them,
Yeah.
and then creating one.
Exactly,
model.
yeah. And checking how the outputs, how the equity multiple and the IRR are changed with these 10,000 different values.
Okay.
Yeah. Right. This is what we want to do now. You're clicking on simulation, start a simulation. Yeah, you don't see that much. I mean, you just have in the left corner the iteration steps. So that's not what I assumed. Happens here. All right. So somewhere's a mistake. To check what you implemented as output and as distribution, you could display this when you are clicking on Modellfenster. I'm not sure what this means in English. And here you can see all your all the things you just set as input and output. And here, for example, we have the exit yield and the construction costs. And as output, we have an IRR and an equity multiple. And here you also could, for example, delete it, or you can make some adjustments regarding your inputs and outputs. So I didn't expect that I have to do this right now, but it's not working. Alright, and the interest rate is completely missing. So now all the inputs are taken into account, which I want. And I think the mistake was that it was adjusted to the best case, not to the base case, because this will influence the calculation here, because we told at risk that it should refer in all his calculations to the first row, first column, and this is the base case. So this might be the reason. All right. So I do a restart. Alright, so now it did work. So the mistake was that I just told the Excel sheet that it should use the best case, and then of course in the developer calculation is used there are the input parameters used for the best case and not for the base case, and then the change is like nothing because there couldn't be something changed. Okay, so now we want to interpret the output, and we defined the IRR and the equity multiple as our output cells, our goals we want to look at, and you just click on the IRR and then you press the button show results, and then automatically the results are shown after you did the simulation for the change of the IRR. And here you see, maybe Adrian, what you mean, like for example with a percentage of 5, so let us also change this. With a percentage of 5%, you're getting an IRR which is lower than 16.88%. Yeah, and with a percentage of 5%, you're getting an IRR which is higher than 25.86%. So this is the output for the IRR. Then also the equity multiple. This comes afterwards. You could define with a percentage of 50%, your IRR, your equity multiple is higher than 1.7264, and there's zero, or there's a percentage of 0 that your equity multiple will be higher than 1.9. So this is referring to your adjustments or to the range you defined, and that's the reason because you're not getting a value higher than 1.9.
But there's also 0% chance that you're getting an equity multiple below 1.5, right?
So depending on, for example, there's only a chance of 1% that it's lower than 1.6, for example. Yeah, with the given parameters, of course. You can, for example, you can lower your construction costs, then of course your equity, you can raise the construction cost, and then of course your equity multiple will be lower, or the risk will be higher than it's lower than 1.6, for example.
And if I change my parameters now, will the simulation automatically adjust?
No,
or
you have
reload?
to you have to restart again. Yeah. Okay. So then you can show a cumulative ascending of the value, and very important, you could display the tornado charts. And yeah, here you see how the KPI equity multiple is influenced by the different input parameters, and you see that the interest rate influences the equity multiple only in a very small scope, and the construction costs, they have the highest influence in our model towards the equity multiple. So you can see there that the construction costs are the most sensitive parameter in this model, for example. Let's have a look at IRR. And there also the construction costs are influencing this KPI most. And this was our goal, like to know which KPI or which input parameter is the most sensitive one, and because then you have to maybe rethink about these input parameters and to adjust them maybe a little bit more detailed. And yeah, for that, or with this, you also have like for a company which is investing in you, or they want to see, for example, which input parameter has the highest risk influence, and in this case it would be the construction costs, and depending on their risk attitude, they will say it's a go or it's a no-go maybe. Because if they say, okay, the construction costs are quite uncertain, where you or how much you have to pay for construction works in 2 years, then it will be maybe a no-go for them. Okay, so this was the at-risk simulation. You have the option to display different charts, and this could be summarized, or to have a good output for your simulation results. You could use the button Excel reports, and there the quick reports, Schnellberichte, are quite good, and they are sufficient, I think. And then a new Excel file opens with all the outputs you just simulated, and you could use it, for example, for your documentation or your presentation. Yeah. This is the same what we just saw, like in a very condensed way, and there you have some information about the IRR, and because we also defined the equity multiple as an output cell, you have in another sheet the details for the equity multiple, and the different charts. So yeah, any questions?
Can we have the table?
You could have the output, the quick report, but not the Excel sheet.
Okay.
Yeah. But I recorded all the whole workshop, and so I provide you with this, at least.
And is this enough?